Today we will be solving polynomial equations by factoring. So remember we talked about factoring at the beginning of the year. So step 1, you're going to move all the terms to one side and set the equation equal to 0. Then you're going to completely factor the polynomial. And then you're going to set the factors, each individual factor equal to 0, and solve for the x. So some of them we will use square roots to solve, or we could use completely a square, but I think the quadratic formula is easier, just for sake of it works all the time, and we don't have to worry about it. And then we're going to simplify all irrational and complex solutions. So we're going to stick with our evens here. We're going to do the evens in this section, just so we don't have to do all of the problems. So we have 4x cubed minus 7x squared equals 3x squared. So I'm going to move the 3x squared over. And when I do, I get 4x cubed minus 10x squared equals 0. So you see here that there is a greatest common factor of 2x squared. And when I take out a 2x squared, I get 2x minus 5. And I'm going to set that equal to 0. So I'm going to take 2x squared and set it equal to 0. And 2x minus 5 and set it equal to 0. And so here I'm going to divide by 2. So x squared equals 0. And if I take the square root of 0, I'm still going to get 0. So x equals 0. But it has a multiplicity of 2, as we talked about in our zeros section. And then this other thing over here, this other factor at 2x equals 5. So x equals 5 halves. So my solutions are 0 and 5 halves. I'm not asking for multiplicity here, I just want you to understand where it comes from. Moving on to number 4. So I have 5x to the 5th minus 80x. So 80 and 5 are both divisible by 5, and they both have an x, so I can take out an x. And then I'm left with x to the 4th minus 16 equals 0. So notice here that this thing is a difference of squares. Even though it's to the 4th, it's still a difference of squares. So I'm going to leave the 5x on the outside. Then I'm going to have x squared minus 4 and x squared plus 4 equals 0. But then notice here that this guy is also a difference of squares. So I'm going to have 5x equals x plus 2 and x minus 2. And then I still have x squared plus 4 equals 0. So what I'm going to do is set all these little guys equal to 0. So 5x equals 0, x plus 2 equals 0, x minus 2 equals 0, and x squared plus 4 equals 0. So when I divide 0 by 5, I still get 0. X equals negative 2, x equals 2. And this is the fun one. X squared equals negative 4. Square root both sides. When I take the square root of a negative number, it becomes an I. And when you take the square root of just a number, put a plus or minus in front of it. So my solutions are 0, 2, negative 2, and plus or minus 2i. And so I had x to the 5th up here. And so I have 1, 2, 3, 4, but the negative one's also gives me 5. So I have 5 solutions here. Moving right along, let's zoom back out to number 6. So I have 8x to the 5th minus plus 5x squared equals 4x squared. So what I'm going to do is get everything on one side. And when I do that, I'm going to get 8x to the 5th plus x squared equals 0. And I can take an x squared out. And then I'm left with 8x cubed plus 1 equals 0. If you don't remember what this is a sum of cubes, which factors with the SOAP formula. So SOAP is our favorite thing to use, right? Same, opposite, always positive. So when I factor this, I get x squared on the very outside. And then remember, a is 2x and b is 1. So 2x plus 1 times 4x squared plus 2x plus 1 equals 0. X squared equals 0. 2x plus 1 equals 0. And 4x squared plus 2x plus 1 equals 0. X squared equals 0, so x is just 0 with a multiplicity of 2. 2x plus 1 equals 0, so I get x equals negative 1/2. And this is the fun one because I have to use quadratic formula. So x equals negative 2 plus or minus, because this is a, b, and c, plus or minus the square root of 2 squared minus 4 times 4 times 1, all over 2 times 4. So I get negative 2 plus or minus the square root of negative 12 over 8. This simplifies to negative 2 plus or minus 12 breaks into 4 and 3. So 2i square roots of 3 over 8. You can Mickey Mouse them. They're all divisible by 2, so you get negative 1 plus or minus I square roots of 3 over 4. So my solutions or zeros are 0, negative 1/2, and negative 1 plus or minus I square roots of 3 over 4. So you're probably wondering, how did I get 5 solutions though? Well, there's 2 here. 2 solutions there. This has multiplicity 2, and this has multiplicity 1. So 2 plus 2 is 4, plus 1 is 5. We're good to go there. Moving right along. If we have 16x cubed minus equals 54, I'm going to subtract it over. They're both divisible by 2. So I can get an 8x squared cubed. Helps if I read it correctly. Change that to a cubed. Minus 27 equals 0. Notice once again that this thing right here is a difference of cubes this time. We're still going to use SOAP. A is 2x, and b this time is 3. So I have a 2 on the outside, and then I get 2x minus 3 times 4x squared plus 6x plus 9 equals 0. So when I do this, 2 never equals 0, so it doesn't work. It's not even a thing to talk about. Other than it's not a solution. I'll leave it there though. 2 never equals 0. 2x minus 3 equals 0. So x equals 3/2. And then this is our fun one, where we use our quadratic formula since it doesn't factor. X equals negative 6 plus or minus the square root of 6 squared minus 4 times 9, all over 2 times 4. Negative 6 plus or minus the square root of negative 108 over 8. Then you simplify, because I can't leave it like that. Negative 6 plus or minus 6i. It helps if I write it neatly so you can read it. Plus or minus 6i, square roots of 3 over 8. Once again, I can Mickey Mouse. Negative 2. Nope, just kidding. I'm dividing by 2, so I get negative 3. Sorry. Plus or minus 3i, square roots of 3 over 4. So 3/2 is one of them, and then this lovely thing is my other one. Alright, we're moving right along. Let's do number 10. So let's combine everything to the left side and keep our x to the 4th positive. So I get 10x to the 4th minus 10 equals 0. So I can take out a 10. And then I get x to the 4th minus 1, which, if you remember, is a difference of perfect squares. Even if you don't, it is a difference of perfect squares. So I get x squared plus 1 and x squared minus 1 with a 10 out front. X squared plus 1 doesn't factor, but x squared minus 1 does. So 10 never equals 0, so that doesn't really matter. You don't have to write this every time. You don't have to write that every time if you don't want to, as long as you know that it's not a factor. Don't tell me that 10 is a 0, because I will count it wrong every single time. X squared plus 1 equals 0, x minus 1 equals 0, and x plus 1 equals 0. So here I have x squared plus 1, x squared equals negative 1, square root both sides, x equals plus or minus I, and then x equals 1 and x equals negative 1, or x equals plus or minus 1. So my solutions are plus or minus I and plus or minus 1. So let's move right along to number 12 here. So I should get 6 solutions, right? Everything is looking all right so far. So I can take out a 2x squared and everything. Then I'll be left with x to the 4th minus 5x squared minus 24 equals 0. So when I do that, this trinomial here factors just like the regular trinomials with the squared. The only difference is our terms are going to be x squared with something and x squared with something. So it multiplies to negative 24 and ends to negative 5, negative 8 and positive 3. So x minus 8 and x plus 3. And then you got to bring down your 2x squared. Neither of these are perfect squares. 3 is not a perfect square, 8 is not a perfect square, so I don't have to do anything else with the x squared part. If they were perfect squares and it was a minus, you'd have to factor it further. But since it's not, we're good. So I'm just setting them equal to 0. So 2x squared equals 0, so x is just 0. X squared equals 8. Square root both sides. X equals plus or minus 8 breaks into 4 and 2. So 2 squared roots of 2. And x squared equals negative 3. Square root both sides. X equals plus or minus I square root of 3. So I have lots of solutions here of 0. Plus or minus 2 square roots of 2. And plus or minus I square roots of 3. So 14 just factors some more. It works the same kind of way. And same with 15, same with 16. So I will stop here